Hello. In this video, I will do a time ASVAB math knowledge practice exam. So let's begin. Okay. Let me see if I could try to zoom in. Yeah, here we go. Okay, so let's start with question one. We are time. Let's see if we could do this in 30 minutes. So question one says, we got to simplify 3 radical 3 minus 2 square root of 18. So what you have to do is you want to put it in a common base. So you basically want it, for example, if it was 3 square root of x minus 2 square root of x, see how inside they both have an x? That's what you want because now all you got to do is subtract the 3 and the negative 2, which is 1, and then this square root of x stays the same. Okay, that's what we want to do. So we got to simplify this. So how do we simplify the first term? 3 square root of 32. I know square root of 32 is not perfect, but we can break it down using a factor tree. So what two numbers multiply 32? Um, maybe 8 and 4. And then, yeah, then what you want to do is circle your prime numbers. So 8 and 4 are definitely not prime. 4 could be broken down as 2 and 2. Circle, circle, right? Circle the prime numbers, and then 8 could be broken down as 2 and 4. Circle 2. 4 is not, it could be broken down as 2 and 2, right? Okay, so it's the circle ones we care about. That's our prime numbers. Then what you want to do is look at the number here. If there's no number here, that means there's an invisible 2. Okay, so if there's no number, there's an invisible 2. And what that 2 means is you circle pairs of 2s. Not the number 2, but a pair in general. So of of your prime numbers. So we don't care about this 4. So do you see a pair of 2s? Yes. You see this 2 and 2? That's a pair of 2. So that becomes 2, and you put that outside the radical. See another pair? Yes. This 2 and 2 just becomes 2, and you put it outside the radical. And then inside the radical is your leftover prime number. So what is our leftover prime number? Or this one, this extra 2. Okay? And then don't forget, be careful, you have a 3 here. Okay? So when you put it all together, what's the left side is going to be 3 times 2, which is 3 times 2 is 6, times 2 is 12. Okay. Now let's do the same thing here. So 18. I know square root of 18 is not perfect, but you definitely can break it down. So what two numbers multiply 18? 9 and 2. 2 is prime. 9 is not. It could be broken down as 3 and 3. Okay. Then what you want to do is circle pairs of 2. So do you see a pair? Yes, I see this 3 and 3 is a pair. So you put that outside the radical, and then inside is your leftover prime number, which is 2. But be careful, you have this extra 2, so make sure you bring that down. So what's 2 times 3? 6. So it's a minus because there's a minus right in the middle. And then it's going to be 6 radical 2. So as you can see, they both have a radical 2 here. That's good. That's what you want. So all you got to do is subtract the 12 and the negative 6, which is positive 6. And then you're just left with your square root of 2. You just leave this alone. So this is my final answer. 6 radical 2. Okay. Question 2, solve for x. If we have x over 4 plus x over 3 equals 7. So this one's a little bit difficult. You can't just cross multiply because there's 3 sides, right? I'm going to put a little invisible one on the denominator of 7 because you'll see why. So first thing I would do to solve for x is get rid of the fraction. And how do you get rid of the fraction? You're going to have to multiply all sides by the LCD. Well, can be a little bit tricky. Uh, did you know the LCD? So you look at the numbers on the bottom to find your LCD. You have a 4, a 3, and a 1. Make sure it's in the most primest form. So 4 is not in the most primest form. 4 could be broken down as 2 and 2. That's the same thing as 2 squared. 3 is a base of 3 that can't be broken down, right? 1 is prime. You can't break that down. Okay. So once you have it in the most primest form, what you want to do is look at the base. If you have a repeating base, pick the one with the highest power. If you don't have a repeating base, meaning if they're all different bases, just put them all together, multiply it. So we have a base of 2, we have a base of 3, and we have a base of 1. Are any of those bases repeating? No. So what you want to do is put it all together. So it's going to be 2 squared times 3 times 1, right? And what is 2 squared? It is 4 times 3 times 1, and then 4 times 3 times 1 is 12. Okay, so that is my LCD. So what you're going to do, I'm going to use a little bracket, and that means we're going to multiply all three sides by 12. This is a 4. Okay, so what is 12 times x over 4? So what you could do is you could do the long way, 12 times x over 4. When you're multiplying fractions, you technically multiply across. So what's 12 times x? 12x. What's 1 times 4? 4. And then that simplifies as 12 divided by 4 is 3, so that's 3x. Okay, you could do that way, or what I like to do is I like to simplify. I know that 12 divided by 4 is 3, so that 3 stays on the top, and then you're still left with the x. That's what I do. We get the same results, right? So plus, what is 12 times x over 3? Well, I know that 12 divided by 3 is 4, and then you still have this x. And then don't forget the right side. What's 12 times 7? Without a calculator, because you can't use the calculator. 7 times 2 is 14. Carry the 1, that's 84. Okay. Now go ahead and try to solve for x. So now what I'm going to do is um, combine like terms. I want to solve for x, but before I move things around, always check if you can combine like terms. So on the left, you have 3x plus 4x, which is 4, 5, 6, 7x. And then you have 84. Then what I want to do is to solve for x, I'm going to get rid of the 7 by dividing both sides by 7, right? So you get 84 over 7, which without a calculator, you could do the box. 7 goes to 8 once, bring down the 1, and then bring down the 4. 7 goes into 14 twice. Okay, so that's how I got D, 12. Okay. Okay, question 3, round to the nearest 10. We have 5/12 over 7, so I don't like that slanted line. I'm going to just rewrite it as 5 over 12 over 7. So they want you to round this because you have what's called an improper fraction. And what you want to do, I can't spell, improper, what you want to do is make it mix or make it as a decimal. So because the numerator is bigger than the top, you can do that. So do the box. The numerator always goes inside the box. So 5/12 goes inside the box. 7 is outside. So I know 7 is too big for 5, but 7 is perfect for 51. How many times does 7 go into 51? About? Um, 7 times 6 is 56. 7 times, so 5? Because 7 times 5 is, oh, 35. Wait, what's 7 times 6? 42. So actually, we can go higher. About 7, 49, 8, 56. So it's going to be 7. Okay, so 7 times 7 is 49. 51 minus 49 is 2. Bring down the 2. How many times does 7 go to 22? About 3. 7 times 3 is 21. And then 22 minus 21 is 1. Then what you want to do is put a little decimal because we have to keep on going. Put a decimal after 3. Bring down the 0. How many times does 7 go to 10? Just once. Do we stop here? No. Even though this is technically the tens, you need to go one more place because you have to look at the neighbor. So what's 10 minus 7? 8, 9, 10, 3. Then bring down the 0. How many times does 7 go to 30? About not 5, but maybe 4. We can stop here. Okay, so we have 73.14. 1 is technically the tens place, but we had to get this 4 because we have to look at the neighbor. If your neighbor is 5 or above, you gotta round. If it's not, you leave it as it is. So it's just going to stay the same as 73.1. Okay, this one, question 4, evaluate 4y minus 5 when y equals 6. This is pretty simple. You're not going to get any letters, you're going to get a number. So this is like saying 4 times y. So wherever you see y, just replace it with 6. So it's 4 times y, or 4 parentheses 6 minus 5. What's 4 times 6? 24 minus 5. What's 24 minus 5? 19. Okay. There's no way I'm going to finish this in 18 minutes because I'm explaining these right. So I'll probably, let's see if I can finish this in 17 minutes. Okay. Question 5. If b equals 3/4, then what is 1 over b? So you have what's called a complex fraction. So yeah, how do we do this? So it's 1 over b, and my b is 3/4, right? That looks a little bit off, but it's a complex fraction. So all you need to do is note that 1 is your numerator and 3/4 is your denominator, right? Once you can verify that, you're going to rewrite this problem. So this is equivalent to saying 1 divided by 3/4, okay? Or 1 over 1, right? 1 over 1 is the same thing as 1. Then what you could do is change this divide sign, or you can cross multiply, or you can change this divide sign into a multiplication, but you would have to flip this, so this would be 4/3. Okay. Then when you're multiplying fractions, you multiply across. So 1 times 4 is 4, and then 1 times 3 is 3. So that's how I got 4/3. Question 6. Find the diagonal of a square whose perimeter is 32. So first, I would draw an image. Okay. And what do we know about a square? We know that in a square, all sides are the same. And we got to find the diagonal. So this would be the diagonal. Okay. And did you also know in a square, each corner is 90 degrees? Okay. So how do we find this length? Well, somehow it forms a right triangle because of this box symbol. This 90-degree means it's a right triangle. So there's a good chance we can use Pythagorean theorem. But we're going to need at least two side lengths. Um, yeah, we need at least two side lengths. So how do we know any side lengths? Kind of. They tell us the perimeter is 32. So if you add up all the side lengths, it equals 32. So all you got to do is divide 32 by 4 to find each side lengths, right? So 32 divided by 4 is 8. So that means each side is 8. Okay. So if you now we can get somewhere. Now, if you look at this triangle right here, it forms a right triangle and it forms these two legs that are 8. Now, how do we find this hypotenuse? Because that's what we want, that diagonal hypotenuse. So we can use the Pythagorean theorem. So a squared plus b squared plus c squared. So a is a leg, so one of my leg is 8. And then my other leg is 8 equals c squared. So what is 8 squared? It's 64. What is 8 squared? 64 equals c squared. Okay. So what's 64 plus 64? It is 128 equals c squared. Okay. Continue solving for c, so you take the square root of both sides. So c is square root of 128. Now, you don't see our answer because they want it in they simplified this square root. So I know square root of 128 is not perfect, so you have to do your factor tree. So what two numbers multiply 128? It could be any two numbers. So I did 4 and 32. Okay. 4 is not prime, it could be broken down as 2 and 2. 32 is not prime, it could be broken down as 8 and 4. 4 could be broken down as 2 and 2. 8 could be broken down as 2 and 4. And then 4 could be broken down as 2 and 2. Okay. Um, then what we do is, remember we look at the number here. If there's no number, there's an invisible 2. So what we do is circle pairs of 2s. So a pair in general, so of your prime numbers. So here we have a pair of 2, so that becomes 2, and you put it outside. Any other pairs? Yes, this is another pair. That 2 and 2 just becomes 2, put it outside. Then you have this other pair. That 2 and 2 just becomes 2. And then inside the radical is your leftover prime number, which is this extra 2. So when you put it all together, 2 times 2 times 2, that's 4 times 2, that's 8 radical 2. So that is B. Okay. Yeah, I'm not going to finish this in 12 minutes, but let's see what happens if they let me finish. Okay, question 7. If x plus y equals 10, what is 4x plus 4y? So you do not have to solve for x and y. So just look at the relationship. The x plus y is almost similar to this. How can I make x plus y make it look like a 4x and a 4y? You can do that by multiplying this by 4, right? If you FOIL out this 4, you're going to get 4x plus 4y. But you also got to do it on the other side because that's the rule. Okay, so I'm going to multiply both sides by 4. So what happens is this is going to be 4x plus 4y. And then on the right, 10 times 4 is 40. Okay, so you just found your answer. 4x plus 4y equals to 40. So letter C. Okay, question 8. 30 is 25% of what number? So Yeah, when you're dealing with percentage problems, there's a few terms that you need to know. If you ever hear the word is in a percentage problem, is it's always going to be equal. Um, Percentage, there's a lot of way you can express percentage as a fraction, like over 100. So, for example, 25% would be 25 over 100. You can also write 25% as a decimal by moving it two places to the left. It's really up to you. The word of always means multiplication in percentage. The word what is your unknown, so you can call it X or whatever letter you like to call. So put that in mind, and then somehow we're going to come up with equation. So it's going to be 30 is means equal 25%. You can write it as two options. You can write it as 0.25 or you can write it as 25 over 100. I'm just going to write it as a fraction. Of means multiplication, so I'm just going to put a little parentheses. That means multiplication. What is our unknown? Call it X. Okay. Put it all together. 25 times X is 25X over 100 equals to 30 or 30 over 1. So your goal is to solve for X. So now what I'm going to do is cross multiply. So it's going to be 30 times 100 equals to 1 times 25X, which is 25X. So what's 30 times 100? Simple. You just add three zeros. Equals to 25X. Divide this by 25. Divide this by 25. What's 3,000 divided by 25? 120. Okay. So your answer is D. Okay. Number 9. If a rectangle has a length of 24 inches and a width of 10 inches, what is the perimeter of the rectangle? Okay, so if you want to draw a rectangle, perfectly fine. And a rectangle, unlike a square, none of the sides are the same. Although this side is congruent with this side, and then this side is congruent with this side. That's it. So this side could be your length, which is 24 inches. And then this side could be your width, which is 10 inches, right? So we want to find the perimeter. So basically you add up all the sides. So we say that this side is congruent with this side. So this is 10, and then this side is going to be 24. So if you add up all those sides, you'll get your perimeter. But oh, we have a problem. What is my problem? They want to know where in inches, and we want to know in feet. So what I'll do is first find it in inches, then I will convert it to feet. You'll see. So what is the perimeter? So you can add up all the sides, or you can use the formula 2 lengths plus 2W, right? Right? If you don't like that formula, just add up all the sides. So it's 2 times length. So my length is 24 plus 2 times W, which is 10. So what's 2 times 24? 48. 2 times 10 is 20. What's 48 plus 20? 68. But keep in mind, we're in inches. So how do we convert that to feet? So you're going to have to do some kind of like fraction or stoichiometry. So you probably learned this in chemistry, but we know that 1 feet is equal to 12 inches, right? So I'm going to put inches on the bottom because remember when you're multiplying fractions, you multiply across and the inches will disappear. And I'm going to put feet on the top because that's what we want. So we know that 1 feet equals 12 inches. So it's going to be 1 and then 12 here. And then just multiply across because this is technically a fraction. So 68 times 1 is 68. And then 1 times 12 is 12. And the inches disappear and you're left with feet. But as you can see, we wanted decimals because this is improper. So do the box thing. How many times does 12 go into 68? About 5, right? 12 times 5 is 60. Bring down the 8 and then put a decimal here. Bring down the 0. You obviously don't have to go any further. You know it's going to be B, but if you want to go further, how many times does 12 go into 8? About 6. Because that would be 72. 80 minus 72 is 8. Bring down the 0. It's just going to keep on repeating. And that means your answer is it's just going to be 5.67. Because I don't see any other 5, so you don't really have to go any further, right? Okay, question 10. We have some kind of PEMDAS problem, pen order of operations. So PEMDAS. So we have 5 minus 2 times 4 minus 12. I don't like the slanted line. I'm just going to make it completely horizontal. It makes it easier. So what I'm going to do is, do we have a parentheses? Yes. Our parentheses is 5 minus 2. So you do the parentheses, and there's only one order of operations, which is subtraction. So 5 minus 2 is 3. Then what you want to do is bring down what you haven't done, because it can get you can make a mistake if you forget. So once we do our parentheses, start PEMDAS all over again. So do we have an exponent? No. Do we have a multiplication? Yes. Our multiplication is 3 times 4, which is 12. Then bring down what you haven't done. Do we have a division? Yes. Our division is 12 divided by 4. Keep in mind there's a minus, so 12 divided by 4 is 3. And then do we have addition? No, but we do have a subtraction. So 12 minus 3 is 9. Okay. What is the greatest common factor? Greatest common factor of 18 and 27. So what I tell my students to find the greatest common, this is not the same thing as LCD. To find the greatest common factor, think of a number that they're both divisible by, and it has to be the largest. So you don't really have to make the factor tree. You could just look at choices. Does 3 go into 18 and 27? Yes. But can we go any higher? Yes, we could try 9. Does 18 and 27 are divisible by 9? Yes. What about 18? 18 divided by 18 works, but 27 over 18 is a no. So 9 is the only choice. So the greatest common factor is you could think of this as a number that they're both divisible by, and it has to be the largest, right? So I'm going to say B. Okay, this one, another percentage problem. So let's figure out what we do. So 12 is what percent of 80? So 12 is going to be 12. The word is going to be equal. What percent? So what is an X? Percent, remember we said we can write percent as a fraction, so you can say over 100. The word of means multiplication, or you could put parentheses, 80. Okay, clean this up. So what's X times 80? 80X over 100. Okay, you want to solve for X so you can cross multiply. But before I do that, I'm going to try to reduce to make my life easier. So 80X over 100 definitely can get rid of the 0. So you're left with 8X over 10. Then what you could do is reduce it even more. 8 over 10 can be reduced by at least 2. So 8 divided by 2 is 4. 10 divided by 2 is 5. Now you may cross multiply because there's only two sides, right? So go ahead and cross multiply. So it's 12 times 5 equals to 1 times 4x is 4x. Well, what is 12 times 5? 60 equals to 4x. And then solve for x by dividing both sides by 4. And then 60 divided by 4 is 1. 6 minus 4 is 2. Bring down 0. That's 15. So it's good. Yeah, 15%. Oh no. Okay, I didn't finish, but I'm gonna finish. Let's see. I'm gonna view my results. So I'm gonna continue. View questions. So what number did we stop on? We stopped on. So we did everything right. It's just that we didn't finish it because yeah, everything looks good. Okay, we stopped here in question 12. So the reason why I couldn't, this is time, right? The reason why I have to explain it. So that's why I'm taking my time. So in the real exam, you kind of have to go kind of quick because you are timed and you can't use a calculator. So let's continue with 12. I'll do 12 again. So 12 is what percent of 80? So it's going to be 12. The word is equal. What is unknown? Percent, you can write percent as a fraction over 100. The word of means multiplication or use parentheses. And then what's 80 times x? 80x. Okay. Then I'm going to try to get rid of these zeros. So you have 8x over 10. And then before I cross multiply, I can reduce the 8 and 10 one more time by 2. 8 divided by 2 is 4x. 10 divided by 2 is 5. Then you may cross multiply. So 12 times 5 is 60. And then 1 times 4 is 4x. Okay, go ahead and solve for x by dividing both sides by 4. And you get 60 divided by 4 is 1. That's how they got 15%. Okay, let's do this one. Okay, question 13. If y equals 2, then negative 3y squared plus 4y equals negative 5. So we just got to plug in y for 2. So it's going to be negative 3, wherever you see a y, plug in 2. That's 2 squared plus 4 times 2 minus 5. So it's a little bit of PEMDAS, order of operations. So do we have a parentheses? We do, but it's already been done. There's nothing you can simplify inside the parentheses. Do we have an exponent? Yes. Our exponent is this 2 squared, so do that first. What's 2 squared? 4. And then bring down what you haven't done. I know it's a pain, but if you do that, you won't get it wrong. Do we have a multiplication? Yes, we have 2. Negative 3 times 4 is negative 12, plus 4 times 2 is 8, and then bring down that negative 5. Okay, do we have a division? No. Do we have an addition? Yes, and we also have a subtraction. So if you have both addition and subtraction, just go from left to right. And that goes the same thing for multiplication and division. If you have a multiplication and division at the same time, just go from left to right. So that's what I'm going to do. So what's negative 12 plus 8? That is 9, 10, 11, 12. That's negative 4. And then you have this negative 5. So what's negative 4 and negative 5? It's definitely negative 9. So why is this negative 9? So you could think of a money scenario. You could think of money, then minus means you owe someone. So you owe someone $4, and then you owe someone $5. So you owe in total negative 9. Okay, question 14, solve for x. So we have 2x plus 5 equals 9. So we're dealing with one-step and two-step equation. So when you're dealing with one or two-step equation, this is here. I'm going to write out the rules because it can get complex. First rule is before you move things around, check if you can collect like terms. Okay, so that's what I will do first. Step two is once you move the if you can collect like terms, get all the variables, and when I say variables, I mean all the letters and all the constant on one side. Okay, so when I say constant, the one without a letter, step three, solve for the variable. Okay, so look here. Here's the left. Here's the right. So step one, can we collect like terms? So on the left side, we have a 2x plus 5. Can we collect like terms? No, because this is a variable, this is a constant. They don't mix. On the right, you're just left with 9, so you can't do much. Step two, get all the variables and all the constant. So because we only have one variable, I'm just going to get all the constant on one side. So what I'm going to do is move that 5 to the right by subtracting 5. Okay, so 9 minus 5 is 1, 2, 3, 4, 5. That's 4. And then I'm going to solve for x by dividing both sides by 2. I mean, now I'm going to do step 3, solve for the variable by dividing both sides by 2. So I get 4 divided by 2 is 2. Oh, I thought this is already done. It's A. So yeah, correct answer is A. Yep. See, 2. Question 15. If 4x minus 3y equals 10, find y when x equals 2. So you could plug in x now, plug in x for 2. So that'd be 4 times 2 minus 3y equals 10. So 4 times 2 is 8 minus 3y equals 10. Okay, so what I want to do is solve for y. So step one, collect like terms on both sides. So on the left, can you do anything? No, because this is a variable, this is a constant. On the right, it's just 10. Step two, get all the variables and constant on one side. So we only have one variable, so I'm just going to get all the constant on one side by subtracting 8. What's 10 minus 8? 2. Step three, solve for the variable. So I want to solve for y, so I have to get rid of this negative 3 by dividing both sides by negative 3. So that's how I get y equals negative 2/3. There you go. That is your answer. C. See? Negative 2/3. Okay, so I've learned my lesson. I'm definitely not going to do a time. Maybe I should just leave it, just submit the test and then just go over the problems more slowly because I kind of rushed on the first part. So yeah, okay, I will stop here.